Hi, today we're going to learn about factors and multiples. Go ahead and start off by writing the objective to identify factors and multiples of a number. Also, don't forget to write your page number 2 in the bottom corner. Alright, well first we're going to look at divisibility rules. This is a set of rules that just helps you to find factors more easily. And a factor is just a number that can be multiplied to get a product. Or in other words, it's a number you could divide by. So if I am taking a number and I want to know if 1 is a factor, well, I can look at the trick. It's always a factor. So I can pick any number and 1 is going to be a factor. So I'm going to put a few examples here as we go down. You're welcome to pick your own example as long as it works. So for 1, I'm going to pick the number 23. 1 is a factor of 23. All right, next I have the number 2. So if I want to know if 2 is a factor, the rule says that it has to be an even number. That means the number I start with has to be even. Well, what does even mean? That means that it ends in a 0, 2, 4, 6, or 8. So go ahead and write that on there. Okay? So I can just think of a number that ends in a 0, 2, 4, 6, or 8, and I know that 2 will be a factor. So I'm going to go ahead and pick 28. It ends in an 8, and 8 is even, so I know 2 will divide into 28 evenly. Okay, next one we're going to look at the rule for 3. Well, the rule says sum of digits is divisible by 3. Well, let's look at a few examples of that, because that one's a little tricky. Let's say I have the number 312. Okay? So what I'm going to do is I'm going to add all the digits in this number. So I would add 3 plus 1 plus 2. 3 plus 1 is 4, plus 2 is 6. So I look at the sum of these digits, okay, and I see, is that divisible by 3? Well, 6 is divisible by 3, so that means that this one works. So if the sum is divisible by 3, then I know this original number is also divisible by 3. Okay, let's try another example. How about 532? Okay, so I'm going to start by adding the digits in the number. 5 plus 3 plus 2. Well, 5 plus 3, that's 8, 9, 10. So that's 10. Well, if the sum is 10, is the sum divisible by 3? Well, no. 10 is not divisible evenly by 3. So this does not work. So I could not put 532 here because 3 does not go into that evenly. Okay? So I'm going to go ahead and use 312 as my example. Feel free to do a few more examples of this to really drive in the point. All right, next we're going to look at 4. The last 2 digits are divisible by 4. So again, I can look at these same numbers and use this to help me. So if I look at the last 2 digits of this number, that's just these last 2. I just have to check if these last 2 digits are divisible by 4. Well, 4 does go into 12 evenly, so yes, that means this whole number is also divisible by 4. Let's check this one. 32. Well, 32 is divisible by 4, so that means this whole number, 532, is also divisible by 4. So go ahead and pick a number that you know is divisible by 4. And I'm going to choose 416. Again, I know this works because the last 2 digits are 16, and 16 is divisible by 4. Okay, next one, the rule for 5. The only thing you have to check for this is that the number ends in a 5 or a 0, okay? So, again, if I look at these 2 examples up here, it does not end in a 5 or 0, so that one would not work for 5. This one doesn't end in a 5 or 0, so that does not work for 5. Okay, but a number that does work would say 325 because the last digit is a 5. Again, so I only have to check to see if the last digit is a 5 or a 0. If it is, then I know the whole number is divisible by 5. Okay, next, the rule for 6. Well, it has to be divisible by 2 and 3. So if you've already checked 2 and 3, and they both work, you know 6 will work. So that basically means that it has to be even, and the sum of the digits has to be divisible by 3. So let's go ahead and look up here. This number is even, and I know it's divisible by 3. So this number, 312, would work for 6. If I look at 532, well, I know that it wasn't divisible by 3. So even though it's even, it doesn't matter. Both the rule for 2 and 3 have to work for 6 to work. So let's pick an example. How about 114? Okay, I know it's even because it ends in a 4. And if I add 4 plus 1 plus 1, I get 6. 6 is divisible by 3, so I know it's divisible by 3. 2 and 3 both work, so I know 6 will work. All right, now I've skipped 7 and 8. They technically have rules, but they're very complicated, so we're going to skip through that. And anytime you're testing 7 and 8, you'll just have to divide by 7 and 8 to see if they're factors, and I'll show you that on this example. All right, next one, the rule for 9. This is very similar to the rule for 3. So the sum, which remember sum means to add, the sum of the digits has to be divisible by 9. So same concept up here. I'm going to add the digits, and now the sum has to be divisible by 9. Well, 6 isn't divisible by 9, so I know 312 would not work for 9. I know this one didn't even work for 3, so 10 is not divisible by 9. Okay, so now I need to think of what's another number I could try. How about 918? Okay, I'm going to start by adding the digits. 9 plus 1 plus 8. Well, 9 plus 1 is 10, plus 8 is 18. Is 18 divisible by 9? Yes, it goes in twice. So then I know that this works. Okay, so I could put 918 as an example. Again, let's try one more. How about 275? Well, I'm going to add the digits 2 plus 7 plus 5. Well, 2 plus 7 is 9, but plus 5 more, that's only 14. And 14 is not divisible by 9 evenly, so that one's not going to work. So that would not work for 9. Okay? All right, and our last number is 10, and this one is nice and simple. It has to end in a 0. Any number that ends in a 0 will be divisible by 10. So go ahead and pick a number to write down. I'm going to put 600. All right, so it's really important that you know these rules because they will make your life a lot easier this year. All right, next one is we are going to look at this example, 216. And we're going to decide which of these numbers is a factor of 216. In other words, which of these could I use and multiply to get to 216, or which of these are divisible, could I divide 216 by? Okay? So let's start with 1. Well, the rule says that 1 is always a factor, so yes. This is going to be a yes, and you can just put a Y or an N. And why? Well, because it's always a factor. Just going to put always to signal that. Okay? Next, I'm going to check 2. Well, the rule for 2 says it has to be an even number. In other words, it has to end in a 0, 2, 4, 6, or 8. So I look at the very last digit of the number, it's a 6. That's even, so yes. This will work, and why? Because it's even. All right, now I check 3. Well, remember for 3, I have to do the sum of the digits, so I have to add the digits. 2 plus 1 plus 6. Well, 2, 3, 4, 5, 6, 7, 8, 9. That equals a 9. Is 9 divisible by 3? Yes. So then I know this works. So yes. And my proof is just this exactly. 2 plus 1 plus 6 equals 9, and 9 worked, or was divisible by 3. All right, next 4. The rule for 4 says the last 2 digits are divisible by 4. So I'm going to look at just the last 2 digits, which is a 16. Well, 16 is divisible by 4, so that means this whole number is divisible by 4. So yes, and I'm just going to show that 16 is divisible by 4. That would equal 4. All right, now, rule for 5. Ends in a 5 or 0. Well, if I look at the last digit, it's a 6, not a 5 or a 0. So that's going to be a no. And why? Well, there was no 5 or 0 at the end. Okay? Next, I look at 6. Well, it's actually pretty easy if I've already filled out the chart, because all I have to do is look back at 2 and 3. 2 was a yes, 3 was a yes. So I know that this is also a yes because 2 and 3 both worked. So 2 worked and 3 worked. So there's my reasoning. Okay, now, remember I told you we skipped 7 and 8 for rules. So to check 7 and 8, I'm just going to divide 216 by 7 and 216 by 8 to check and see if they are. So 216 divided by, I'll start with 7. 7 goes into 2 0 times. 7 goes into 21 3 times, which is 21. I bring down, I get a 6. 7 does not go into 6, so that'd be 0, and then I'm left with the remainder. So that did not divide evenly, so I know 7 would not work. And then I could also test 8. 8 goes into 2 0 times. 8 goes into 21 twice, which is 16. I subtract. 11 minus 6 is 5. I bring down 56. 8 goes into 56 7 times, which is 56. And now I have no remainder. So that's good. That means it does work. So in this case, 8 would work if I needed to check. Okay, back to the rules. We look at 9. The sum of the digits is divisible by 9. Well, I've already added the digits right here. 2 plus 1 plus 6 equals 9. 9 is divisible by 9, so that works. So this is a yes. And last but not least, we have 10. The rule says it has to end in a 0. I look at my number. It does not end in a 0, so this is a no. And why? Because it does not end in 0. All right? All right, now we're going to look at some ways to find factors besides using a chart like this. You could do a factor rainbow. So when I do a factor rainbow, I usually start with 1. It's the easiest to just start and go down the line, okay? Well, I know 1 is always a factor, so I'm going to put 1 here, and I think, well, what would I multiply by 1 to find the other number? Well, 1 times 42 is 42. So this is like the outside of my rainbow, okay? You have your smallest and your biggest factor. Then I'm going to try 2. Well, I know the rule says even number. This is even, so I know 2 is going to work. And now I have to think, well, what would I multiply 2 by to get 42? So if you don't know that off the top of your head, you can always divide. I happen to know that half of 42 is 21. So 21 will go here, and there's my next part of my rainbow. Okay, now I'm going to look at 3. Well, the sum of the digits is divisible by 3. 4 plus 2 is 6. 6 is divisible by 3, so 3 will work. Now, it might not be obvious to you how many times 3 will go into 42, so we're just going to divide to the side right here. 42 divided by 3, that goes in once, which is 3. Subtract, that goes in 4 times. All right, well, that worked. So it'd be 3 and 14. Okay, now I'm going to check 4. The last 2 digits. Well, it's only 2 digits. So I really just need to think about this, think about my multiples of 4. I know 4 times 10 is 40, and then 4 times 11 is 44. So 42 will not be hit when I list out multiples of 4, so 4 is not going to work. I'm going to skip it. Try 5. Doesn't end in a 5 or 0, skip it. Try 6. Divisible by 2 and 3. Well, 2 and 3 are both here. So I know 6 is going to be here. And again, if I just think about all my factors, or my multiplication facts, I know that 6 times 7 is 42. And now I found all the factors, because if you have two numbers that are consecutive, you're done. There's nothing that can be in between. So here's all the factors of 42. Another way you can do this, especially when you're finding the greatest common factor between two numbers, is to make a little chart, a T-chart. So I'm going to find all the factors of 24, I'm going to find all the factors of 36, and then I'm going to see what they have in common and find the greatest one that they have in common. All right, so again, when I look for factors, I always start with 1. I know 1's a factor. 1, and then what would I multiply to get 24? Well, 1 times 24. Likewise, I can do the same thing with 36. Okay, I'm going to go ahead and do 24 and let you try 36 on your own. So 2, well, it's even, so I know 2 is going to work. And I know 2 times 12 is 24. All right, now 3. Well, 4 plus 2 is 6. 6 is divisible by 3. So 3. And then let's see, 3 times what? Well, I can think of my multiplication facts, or count by 3s to get there, or list multiples of 3 if you need to. And I know that 3 times 8 is 24. All right, moving on. 4, last two digits. Well, 24 I know is divisible by 4 because I know my multiplication facts. So that would be 4 times 6. Now the only number between 4 and 6 is 5, so really that's the last thing I have to check. Well, 5 is not going to work because it doesn't end in a 5 or 0. So here are all the factors of 24. Go ahead and try 36, and you can pause the video right now to try that on your own. Okay, so now hopefully you've already listed them. We start with 1. 1 is always a factor, so 1 times 36. I go down to 2. It's an even number because it ends in a 6, so I know 2 is going to work. Now let's say I don't know what the other number is, 2 times, I don't know. So I can just divide 36 divided by 2. 2 goes into 3 once. Subtract. 2 goes into 16 8 times, which is 16. So that means my other factor with 2 is 18. All right. Now I check the rule for 3. The sum of the digits, well, 6 plus 3 is 9. And 9 is divisible by 3, so it does work. So we'll put a 3 here. 3 times what? Again, you can divide by 3 if you're not sure, or hopefully you know that 3 times 12 is 36. Okay, then I move on to 4. Well, last two digits, it's only 2 digits, so really I just need to check my multiplication facts. I know that 4 times 8 is 32 and 4 times 9 is 36. So 4 times 9. Okay, let's try a few more things. I can try 5. 5's not going to work because it doesn't end in a 5 or 0. I can try 6. Again, 2 and 3 both worked. So I know 6 is going to work. And if I think about my multiplication facts, I know that 6 times 6 is 36. So I'm done. Now, I'm going to look at all my factors for both numbers, and I'm going to circle anything they have in common. So they both have a 1, they both have a 2, they both have 3, they both have 4, they both have 6, they both have 12. Let's see if there's anything else. 8, 24, no. So I'm done. Well, which number that I circled was the highest or the greatest? In this case, 12. So the greatest common factor would be 12. All right, couple more things. Multiples. So when you are finding a multiple, you're basically just taking the number and multiplying by 1, multiplying by 2, multiplying by 3. Okay, so we're going to list out some multiples of 7. So first of all, I'm going to start with 7, because that'd be times 1. 7 times 2 is 14. You're basically skip counting. 7 times 3 is 21. Go ahead and list out a few more multiples. So this is times 1, times 2, times 3, In general, if it's on my paper, I want it to be on yours. So make sure you're getting everything down. All right, so a few more multiples. 28, 35, and I'm just going to put dot, dot, dot because you could go on forever. And again, this one would be times 4. This is times 5. Okay, so now if you're finding the least common multiple, you're just going to list the multiples of the two numbers and find the first number they have that's the same. So, 6, 12, 18, 24, 30, and I could keep going. I'm going to stop there for now because I've got a good list started. Let's try 8 now. 8, 16, 24, and I can stop because I see that they both have 24 on the list. So I don't need to continue listing any multiples because I have found it. The least common multiple is 24 for 6 and 8. Okay, last thing is we're going to look at this really cool trick. I call it the L way because it makes an L. And this is an actual trick that you can use to find the greatest common factor and the least common multiple in one step. All right, so the first thing you're going to do is you're going to look at 18 and 24, or whatever two numbers you start with, and you're going to see what is a factor or something that I can divide by that goes into both of these numbers. Well, usually a good one to always try is 2 because 2 goes into a lot of numbers. And since both of these numbers are even, I know that I can divide this by 2. So I put the 2 on the outside, and now what I'm going to do is actually divide them both by 2. 18 divided by 2 is 9, so I put that underneath the 18. 24 divided by 2 is 12. I put that under the 24. Then I'm going to make another L. Okay, now I have to see if 9 and 12 have any common factors. Well, 2 doesn't work in this case because 9's not even, so I'd go down the list. 1 doesn't count, so you never have to use 1. The next number would be 3, so let's see. Well, 3, 6, 9, that would work, and 3, 6, 9, 12. So I know 3 goes into both numbers, so I'm going to divide by 3, and I'm going to see, well, what is 9 divided by 3? That would be 3. What is 12 divided by 3? That would be 4. Now, I don't have to make another L, and the reason is I'm left with 3 and 4, and those don't have any common factors, aside from 1, but remember 1 doesn't count. So I'm done here. So now, here's how I find the greatest common factor. I'm going to just look at these numbers that are on the side of the L, okay? I have 2 and 3, and for the greatest common factor, I will multiply whatever numbers are on the side. So I have 2 times 3. Well, 2 times 3 is 6, so the greatest common factor is 6. Okay, when I want to find the least common multiple, I'm actually going to look at all the numbers on the outside of the L's. So all 4 of these numbers. So LCM, or least common multiple, I multiply them all. So 2 times 3 times 3 times 4. That's a lot of multiplying, so let me break it down. 2 times 3, that's 6. 6 times 3, 18. 18 times 4, well, I don't have that memorized, so let me check real quick. 18 times 4, go ahead and work this out with me. 4 times 8 is 32. 4 times 1 is 4, 5, 6, 7. So that means that this is equal to 72. So the least common multiple is 72. And that might be a little easier than having to find all the factors of a number and list out a ton of multiples. You can just use this L way, and then you find both of these in one step. All right, well guys, keep practicing, and I'll see you next time.